Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GRE out of this book here, practicing to take the GRE General Test, the 10th edition. If you do not own this book already, and if you're thinking about sitting for the GRE, it's imperative that you get hold of this book immediately. The problem that I'm about to solve is the one that you're going to find on page number 291, quantitative comparison question, number 5. Let's take a look at it, see what it has to say. Number 5. They give you a picture here, so let me draw a picture here. They tell you that O to X is the same length as X to Y, from X to Y, and we're told that they equal 1. So O to X equals 1 and X to Y equals 1, and therefore O to X is equal to X to Y, and they are both equal to 1 obviously. So immediately we surmise that the radius of the large circle is 2. So let's make a note of it here. Radius of the large circle, I'm just going to call it radius of the large circle, let's call it the big circle, is 2. Let's not change the notation all of a sudden. Since I called it large, let's stick with large. And the radius of the smaller circle is 1, that's an S. They want you to compare the circumference of the small circle here. Circumference of the small circle, circumference is 2 times pi times r. And I hope you know that formula. You have to know it by heart. There is no other way around. There is no way around it. There are some formulae, or as Americans call it, formulas, that you must know by heart. The circumference of a circle being one of them. You have to know how to figure out the area of the circle. You have to know the formula for it. You have to figure out how to find the volume of a cylinder. You have to figure out how to find the volume of a box. You have to figure out how to find the area of a rectangle, a square, how to figure out the surface area of a rectangular box or a cube. These are basic things in geometry that you have to know. I know there is not a hell of a lot you're going to do with it in your life, in your career afterwards, but as they say, this is the only game in town. If you want to get into the college that you want to get into, if you want to get in the graduate program that you want to get into, and they require GRE, so you have to learn these things just for the exam, even though afterwards you have no use for them. So circumference is 2 pi r. 2, and this is the small circle I'm doing here. I'm doing column B. 2 times pi times radius of the small circle, which is 1. So it's basically 2 pi. Circumference of the small circle is just 2 pi. In the first column, in column A, they're telling you, pay attention here, it's very important that you pay attention here, half the circumference of the large circle. Well, half the circumference of the large circle. So here's my circumference of the large circle. They want half of it. So it's going to be again 2 times pi times r. The radius of the large circle is 2. And I want to take half of it. And if I'm taking half of it, this 2 drops out with that 2. And basically, I'm comparing a quantity of 2 pi versus another quantity of 2 pi. And of course, we're making a big fuss about nothing at all, because if this circumference has twice the radius, if this outer circle has twice the radius, if the large circle has twice the radius, then if you were to try to walk around it, you'll end up walking twice as much. The walking around the circle is what is known as circumference in the jargon. And if you're taking, so the distance around the large circle is twice as much as the distance around the small circle. And therefore, if you were to take half the distance around the large circle, going from here and stopping all the way here, that distance should be same as the distance all the way around the small circle. That's all. So 2 pi equals 2 pi, the answer is C. You don't have to worry about what pi is equal to. There is no need to substitute the value of pi and so on and so forth. because these are not called computation problems, these are called comparison. 2 pi, whatever that quantity is, has to equal 2 pi. That's it, the answer is C. Let's move on to the next problem, number 6. I need to erase all of this thing. But before I erase all of this thing, I'm going to quickly look at the camera in the back, see how much time I've consumed so far. That will tell me how to pace myself for the next problem, number 6. Just give me a second. Oh boy, I have taken more than half the time. More than half the time because the YouTube gives me nasty looks when the clips goes over 10 minutes, so I have to keep them under 10 minutes, and I've already taken more than 5 minutes in this one. So let's do number 6. Hence the comment of more than half the time. In number 6 they tell me that P times Q is 0. And then they also tell me that R times Q is 1. Well, before we do T times Q and R times Q, it will be easier for me to speak in terms of A and B, so let's do it here. If I tell you that A times B is 0, what do you conclude from that? What do you surmise from that? What do you infer from that? And if you don't know these words, look them up and learn them. Surmise, R-U-R-S-U-R-M-I-S-E, or infer. Infer. The noun for infer would be inference. So what inference do you draw from the statement if I were to tell you that I'm holding two numbers in my hand, I'm holding one number in this hand and one number in this hand, and I tell you that when I multiply them, their product is 0. If when I multiply this number by this number, which I'm not telling you what they are, but if I tell you that when I multiply them, the product is 0, this is what you should surmise. There are three possibilities. There are three possibilities in this case here. One is that A is equal to 0. If A is equal to 0, then A times any quantity B would be 0. Or B is equal to 0. If B is 0, then whatever the hell the A is, 0 times A would be 0. Or, of course, there is always a third possibility, which is both are equal to 0. And, of course, 0 times 0 would be 0. So that's what's going on here. So let's make a note here. Let's make a note here. From this, that tells me that this implies that either T is equal to 0, or Q is equal to 0, or both T and Q are equal to 0. I'm going to erase all of this thing here because I need to work on the next statement, and I also need to pick up my speed. The second statement that they give us is that R times Q equals 1. Well, there you go. If R times Q equals 1, then neither R nor Q could be 0. Neither of this could be 0, because if either of them were 0, if either R or Q were 0, it's a hypothetical statement, then the product would have been 0. But I'm told that product is 1. Since the product is 1, that tells me, that implies that Q cannot equal to 0. Q does not equal to 0. Well, if Q does not equal to 0, right here, if we're ruling this out, if Q does not equal to 0, then given the fact that T times Q is 0, that when you put both of them statement together, implies that T must be 0. There you go. T must be 0 because T 0 times Q, whatever that is, will equal 0. So T must be 0. And then what we have? Oh, there you go. We have T in the first column. And we have 0 in the second column, column A and column B. And since we just figured out that T must be 0, the answer is C. That's all. There's not much in it. 68% of people who took the exam got this question right. I hope you found it helpful. If you wish to get hold of me for personal private tutoring, face-to-face tutoring, or over the phone or over the internet, or if you wish to get a hold of the solution manuals of any of these questions, or for any reason at all for GRE, if you need help, just call me, or rather go to my website at www.prep.gre.com, or you can go to www.KeshwaniPrep.com and send me an email. All right? Thank you very much. Bye-bye.